Hey, how's it going? It's Lee Halliday, and today what we're going to be doing is learning how to use Intersection Observer. It's an API that's been out for a little while now, but is still pretty new, and what it allows you to do is see when a DOM element is visible on the screen. And the way we're going to do that is by sort of recreating one of the hooks I found on the usehooks.com website, and it's called useOnScreen. So I've already set up a Create React app, and I'll just show what it's doing so far. It's got an app component. That's all we're going to be doing. It's a small demo. And what it does is it displays a div on the screen, two divs actually. One that's 100 VH, so that's this one here. And the goal of this demo is that when I scroll down and I hit around 300 pixels visibility of this other section, it's going to swap and display a GIF. Same as the demo on this use hooks example here. So I've sort of mocked out the variables we need. We're going to need a ref to know when the DOM element is visible on the screen. And we're going to have some state visible sorry, that lets us know if it's on the screen or not. So we've got our first div that's ticking up 100 VH. It's telling us to scroll down. And then we have our other div here, which this is the one that we need the ref for, so we can determine whether it's visible or not. And then we're tweaking the styles a little bit. So if visible is true, it's going to swap the background color from this gray here to this teal or whatever that is. And then we're also changing the content a little bit. So if visible is true, we're going to swap out the content to be this div here that says, hey, I'm on screen, and it will display this GIF. And if visible is false, it will tell you to basically keep scrolling so that we can trigger the event. So right now it does nothing, but that's what we're going to do. So the way we're going to do this is by creating a custom hook, which will be given the same name as this one, useOnScreen. So we'll say function useOnScreen. And what this function is going to receive are some options that we will pass to the Intersection Observer API when we create a new instance of that. So the first thing we need is a ref that basically points to the actual DOM element that we're trying to keep track of its visibility or not. And there's actually two ways to do this. I'll show the first way, and then we'll talk about what problems it might have, and we'll swap that out for another way. So the first way we'll be using the useRef hook. So we'll say ref, and that is useRef, like that. Okay, so this will create us a ref variable that sort of starts out like this. It's an object with a current, and it will be null at the beginning. Okay. So the next thing we need is an effect that will basically run whenever the ref changes, or basically we just want it to run once, the first time that this app component is rendered. So we'll say react.useEffect, and whenever you use useEffect, you pass in a function that gets called. So we'll pass in here. And first things first, you always need to pass an array of variables to watch to see when they change to know when to run this effect function or not. So we're going to be looking at the ref, and just because we're going to be using options, we should also have that in here as variables to watch out for. Okay. So what should our useEffect function do? The first thing we're going to do is we're going to create an observer. So this is using the Intersection Observer API, and this is how it looks like. You say new intersection observer, and the first thing you pass to this object or class being created is a callback function. So this is the function that gets called every time it sort of detects a change in the thing that you're observing. And it's going to pass us basically an array of elements that we're observing because we're only watching one element at a time, we're just going to put an array in here and deconstruct it so that we can pull out the one entry that we're watching. Okay. So when this gets called, we have access to the entry, and the entry tells us a whole bunch of information about the element that we're observing. So what we want to basically do in this example is keep track of some state whether the element we're watching is visible or not. So we need to create our state up here within our hook that we're building. So we'll say visible and set visible is equal to react.useState. And we can start this out as false, just assume it's not visible when we initialize it. And what we're going to do now is use our setVisible function that comes from the useState hook. And we'll say setVisible, and it's going to be equal to the entry. And there's a property on entry called isIntersecting that basically tells us whether or not it's visible on the screen. So if you remember down here, it says scroll down 300 pixels from the top of this section. So whenever you're using Intersection Observer, you can control how visible on the screen it should be before it calls your Intersection Observer callback function. So we'll be passing in those options in this options variable here. So we're just going to pass along those options to the observer. Okay. So the next thing we need to do, we've created this observer, but with the way refs work, it might not always be referencing a DOM element on the screen. So we just need to make sure that it is referencing something before we tell the observer to observe that ref. And that's because it's an object that has a current which may be null at the beginning. So we'll say if ref.current, then we can say the observer should observe the ref.current, like that. So that basically starts the intersection observer observing the DOM element on the screen. So with useEffect, you can optionally return a function that should be called sort of anytime the effect is no longer valid, or when it's basically whenever these variables change, it's like a cleanup function that can be called. So we're going to be returning a function here. And what we're going to do is the same sort of thing. So if there was a current element that this reference refers to, we're going to say to the observer, unobserve that reference. Like that. So it's already giving me a little bit of a warning. We'll just ignore it because I think it still works. And we'll talk about maybe a better way to clean that up. Okay, so we've got this, which is the purpose of this is basically to set up an observer and then to observe the element on the screen. But we need to return something back from our useOnScreen hook. And essentially what we want to return back is the ref and whether or not the DOM element that it refers to is visible or not. So we'll return an array that has the ref as the first item in the array and visible as the second. And what that allows us to do now is to replace these sort of mocked out fake variables with the values that are returned from our useOnScreen hook. So we can say const ref and visible equals useOnScreen. Okay, and remember when we set up useOnScreen, we could pass some options to it. So that will be an object, and the things we're allowed to pass to it are basically any valid options that the intersection observer takes. So we'll just scroll down, and typically the two that you're going to be looking at are root margin, and that's that can be pixels or sort of any CSS property here that measures like distance or spacing. And here we can say we want it to have a root margin of 300 pixels. Because remember, we wanted the user to have to scroll down 300 pixels in order to trigger this intersection. You can also use threshold, which is basically between 0 and 1, a percentage of how much this div should be visible. So if you do 1, it needs to be 100% visible. If you do 0.5, it's as long as it's half visible. But we're going to be using root margin for now, and we'll maybe switch that up later. So we're going to say a root margin of 300 pixels, like that. So now when we come back to our app, you know what it is? Maybe it's minus 300. There we go. So 300 pixels would actually be starting at sort of 300 pixels before it's visible. So that would be really useful. Say you're lazy loading images or something like that. And as the user's starting to get closer to your div or your image that you want to lazy load in, you can load it before the user actually scrolls there. But in this case, we will only want to trigger the intersection 300 pixels after it's been visible. So we can use a negative for that. So as I scroll down, once I get to 300 pixels, it now triggers the intersection. And what do I mean by triggers the intersection? It calls this callback function that we passed into the intersection observer, which calls setVisible to update the state based on whether the entry is intersecting or not. And because we were returning from this function the ref and the visible, we can use this visible property here to know whether we've triggered the intersection or not. So as I scroll down, it turns on, and then as I scroll back again, it turns off. So we can switch this up a little bit. There's the threshold we could use instead. So let's say when it's 0.5, so 50% visible on the screen. So now it's not 300 pixels, but when it's about 50% visible. So you can see it takes up half the screen, and that's what triggers it now. We could set it to like 0.9, and then it has to be 90% visible before it turns on. Like that. So we'll just 0.2, whatever that is, just barely visible. So I mentioned there's a couple ways of using ref in this case. And the reason it works here, passing in ref as one of the values to our useEffect variable array to watch out for changes for, to trigger the effect, is because there's no sort of if logic here of whether or not you should display the ref. It renders every time this div, so it happens to work. Because in effect, it first renders what's on screen, and then the effect is run. So by the time the effect is run for the first time, our ref will already have a value, so it should be okay. But you can start to run into some difficulties with useEffect passing in ref as one of the variables here. If you have logic in your component that optionally displays that element or not. So instead of using the useRef hook, you can use what's called a ref callback to set it instead. And you can do that using state. So here we can say ref and setRef is equal to react.useState, and we'll just set it to null at the beginning. So now inside of ref, it's not going to have a current property. It's actually just going to contain the direct reference to the DOM element. So we don't have to say ref.current anymore. We can just use ref itself, like that. But one little caveat here is instead of returning the ref value, we actually want to return the setRef function to call to modify that state. So here you may want to just switch this up so that you know what's happening here to setRef. And you can pass setRef here to ref. And that's because ref can accept sort of two different things. It can accept something that's returned from the useRef hook, which is an object that has a current property, but it can also accept a function that gets called, and that function gets passed the DOM reference. So we're passing setRef here. That will get called, and it will basically update our state, the ref property, to contain that DOM element inside of here. Let's just make sure it's still working. Refresh this. Point 2, yes, it gets displayed on the screen. So this is potentially a safer way of using ref when you may be optionally rendering the element that you want to hold a reference to. All right, so if this was a lot of work to basically figure out whether something's on the screen or not, you're in luck, and I would probably recommend this by default unless you have a really simple or case that this package can't handle. There's a React intersection observer package that's pretty popular, and it's being developed still. And this basically comes with a lot of that functionality we just created ourselves today, along with some additional functionality. Like maybe there's a function you want to call the first time something is displayed on the screen. I've seen this in New York Times. I don't know if they're still doing this, but as you're reading paragraphs in some of their articles, they're sending up sort of analytics data to their backend. Let's just, for fun, see this. We'll go to our network tab. Maybe they're not doing it anymore, but at some point I believe they were sort of reporting back to the server as you've read certain paragraphs. So you could use Intersection Observer for that. As a paragraph gets displayed on the screen for the first time, you may want to send a post to your backend. Basically, you can keep track of how far down the page the user's read. That's one way to do it. So I would recommend using this package by default. But what I wanted to cover today is basically how to build this ourselves and how to use Intersection Observer API within a React app. So just to review what we covered today, we created our own useOnScreen hook. This hook brings in some options. These options are passed to the Intersection Observer. So that's basically when to trigger the intersection callback function. So whether it's maybe 300 pixels visible on the screen, either 300 pixels before or after, or a threshold of how visible the element is that you're watching. So the first thing we needed is a place to basically store a ref to the DOM element that we're keeping track of, whether it's intersecting on the screen or not. And we looked at two ways to do that, using useState with ref callbacks and also using the useRef state. We also set up some state to keep track of whether or not the element that we're watching is visible or not. So here we have our effect. And this effect, we're passing in the ref, that's the reference to the DOM element, along with the options that we're passing to the Intersection Observer. And what this basically does is it sets up an observer, which has a callback function here. And if the ref has a value, so if there's a DOM element in this variable, we're going to tell the observer to observe that DOM element and to notify us of whenever it's visible on the screen, or it's not visible on the screen, whenever that changes. And then we're passing a cleanup function from our effect, which will essentially, if there's a ref here, tell the observer to stop watching that ref. So from this custom hook that we created, useOnScreen, we're returning the setRef function to be used in the ref callback below, and also whether or not the DOM element that we're watching is currently visible or not. So in terms of its use, we've destructured out those two variables again into setRef and visible, and we're also passing in some options that will be passed to the Intersection Observer. So down here, we've got one div that took up 100 VH of the screen, basically the whole thing. And then our other div, and this is the one we want to create a reference to. And then we're going to modify some things based on whether it's visible or not. So we've changed its background color and also some of the content that's displayed within it. And all of this code here is I basically copied and pasted from the example used on the usehooks.com/useOnScreen example. I would say they have potentially some issues in the example here, only that they passed an empty array to the useEffect hook. So basically they only want it to run once. But as I mentioned, if you have logic that that basically may or may not show the element that you want to keep track of the intersection observer on, this will cause some problems here, because the first time it runs the useEffect, there may not be a ref. So that's where you could run into some issues. But as I also mentioned, the React intersection observer package seems to do a really good job of keeping track of all this complexity for us, and giving you some different ways in terms of how you can use it, like a callback function that only gets called once. Looks like you can use it with render props or as a hook, and so it's a very flexible library. Check it out. Hope you enjoyed this video. I'm not going to share the code because it's essentially the exact same thing used on this page here. I just wanted to explain it. Hope you enjoyed it. Take care. Bye.